Okay, so homework for today, we were messing with classes, right?
Yeah.
So we look at our homework assignment. We were creating a class called car that stores a couple of pieces of information about a car. One is the number of wheels, and the other one is maybe the name of the car. So let's start writing that guy. So I'm going to create another class here, class car. And we're going to keep track of, I haven't talked about private stuff yet, so we'll keep track of int number of wheels, and we'll keep track of string name. So a couple of pieces of information about a car. We are going to have to include string here for that to work for strings. Then we need to give ourselves a constructor for this guy. So the constructor is always named the same as the class name. And this guy is going to take in an int as a parameter and a string as a parameter. And we're going to set our local variables. So number of wheels is equal to number of wheels that was passed in. So this, I'll probably read this as this dot, but we talked a little bit about this last time. We'll talk about it a lot more today. Remind me, what is the this keyword? What does that guy do? Go ahead. Okay, so this is how a variable refers to itself from within itself. Remember at the end of class last time, I was printing out the value of this inside the constructor, and then we were printing out the variable name. Let's see, do I still have it here? I printed out P3. When I created P3, it printed out its address inside. I probably still have that. I called this guy's display. I think what I had in here was cout this and L, something like that. So when I call this constructor, which gets called anytime we call upon the constructor, I was printing out the value of this, which was a memory address. And we would have seen that when I was creating P3, the memory address that was shown was identical to the value that was stored inside of P3. So the variable this within the instance of person class called P3, or called that is associated with P3, the value of this in there holds the same memory address that P3 holds external to that class. And why do we need that? Because if we're inside of that instance of person class, we don't have access to that variable called P3. But we still might want to talk about our stuff. Okay, so that's what that magical this keyword is all about. So in this case here, I'm setting this guy's number of wheels. That is the number of wheels that he owns equal to the most local definition of number of wheels, which happen to be passed in right here. Similarly, I'm going to set this guy's name equal to the name that was passed in. All right, did I say to do anything? Create a display method that displays the car in some way. So we'll go ahead and write a method void. We'll call it display. It takes no parameters. Why doesn't this guy take in any parameters? Because he already knows about this particular car's number of wheels and name. So we'll do something like this name with this number of wheels, something like that. Just some sort of output representing my my car. So we'll go ahead and now create a couple of cars. When I build a car, I give it a number of wheels and I give it a name.
Now, does that matter that you named it void display, but then in the person class it's display as well?
different scope.
Okay,
Open and closing parentheses here. So there's a scope that belongs to car.
okay.
There's a scope
just-
that belongs to person class.
I'm just making sure.
Yep.
So,
Well, but I mean, it's for a very good reason.
Yeah.
Yeah. So you ask the question, the answer is it's a good question, and the answer is a good answer. So just make sure you're not just like, okay, yeah, that's just the way it is. I'm good with that. It's for a good reason, and it involves the stuff we've been talking about with scoping rules.
Yeah.
Yeah. So variables as well as functions boil down to their most local definition, and from the perspective of person class, his most local version of display is right there. From the display of from car's perspective, his most local version of display is his.
Gotcha. I'm just making sure.
Mhm. So down here, we'll go ahead and create a couple of cars. So I'll create a car pointer. C1 is equal to a new car. And we're going to have 4 wheels on a Corvette. And we'll have a car pointer C2, as this is going to be a new car. And how many wheels are on a semi? Is it 18 wheelers? 18 wheels. So 18. That's close enough. Close enough. So then we'll tell C1 to display himself. We'll tell C2 to display himself. Line 39. Oh, I need to put a semicolon right here. And we'll talk about that today. All right. Oh, I probably should put an endel here so it kicks it down a line. So there's our 2 cars, Corvette with 4, well, probably 4 wheels. We'll read a little bit better. Corvette with 4 wheels, semi with 18 wheels. So something along those lines for the homework. This guy right here. All right, questions about that? Okay, now you might imagine that as you start getting into larger and larger and larger programs that start using lots of objects, because I mean, all of our modern programming languages are object-oriented languages, and hopefully we're starting to see that as you solve more and more complex problems, the chances of us inventing our own object types is going to go up. So already we have 2 different classes we've defined, a person class and a car class. We can imagine as things get more complex, we're probably going to be creating more classes, right? So you might say, you know what? All programs begin and end with main. So main is kind of the driver of my program. And then I have these other things that I've invented that I'm going to use inside my program, but I want these guys to, I don't want them to clutter the main program. I want to be a little bit more organized with my code. So one thing I could do here is I'm going to take all that code I just had for car, and I'm going to create a new file here. I'm going to call this guy car HPP, and we'll talk about, you actually can call it whatever you want, but we'll talk about that here in a second. So I'll call this guy car HPP. And I'll just go ahead and paste this stuff in here. Now I need to make sure that this guy has access to the stuff he needs. So he needs access to the string class. So I need to do an include string using namespace standard. He also is going to have access to cout. So I need to have IO stream in here. All right, so that's all the stuff he needs access to. So now here in main, I'll go ahead and say, I want to include car.hpp. And notice we get the same output. So what I did is I moved my stuff outside of this main CPP into what's called a header file. Okay. Now, as we're, so let's kind of get into our notes what a header file is. So header files, and actually, as I currently have it described, I've named this file car.hpp, which would be a C++ header file. I've named him that, but I actually am not using him yet as a traditional header file. He would actually exist in two separate files, and I'll show you. Actually, why don't I go ahead and show that example first? So I'll have my car HPP, and now I'm going to create another file, car CPP. And in car CPP, I'll actually have my implementation here. This guy will include car HPP, and he's going to be the one that needs access to the IO stream, although I can just leave it in the other one. It's not hurting anything, so I can leave it here. And then what I would do in here is I would actually remove the implementations. And then inside of car CPP, I would say, this is the constructor for car that belongs to this class. This is the function display that belongs to this class. So the idea here would be is when I look at HPP, and even though this is a very simple class, doesn't have a whole lot going on, I can look at this header file and I can see exactly at a glance what the capabilities of this object are. I don't need to get all wrapped up in the details of the implementation that are over here. And again, this is a pretty short implementation, but you can imagine this could be hundreds of or thousands of lines of code for the very complex projects. All right, so there could be a benefit to being able to glance at kind of the quick start instructions. If you ever get that with one of your electronics or something like that, you just glance at it, it says, look, this is what a car knows how to do. This is how it does it if you are interested in the details, but this is what it knows how to do. Okay, so I've separated those two guys, and this header file, so an HPP file or an old C, it's just a .h file for header file. CPP is a C++ file. All right, these two guys are linked to each other that way. Well, this file knows about that file because I've included it up top. And then the way I've said I am implementing this section is by making sure I put this class name : afterwards. That says I'm giving an implementation to this dude here that I've defined somewhere else, in this case over here. Okay, so this would be kind of your historic way of using header files in old school C and C++, where you have what it knows how to do, the actual how it does it, implementation, and kind of almost self-documenting. We can call this documentation in many ways in separate files. And then when we actually go to use it, we use it inside of our code over here. Go ahead. Oh, okay. All right. Now, for those of you who have worked with some more modern languages, like a Java, you would not have these two files separated. You would have it all in a single file like I originally had it, and it would be under like a .java file. So the question is why? There's actually a good reason for it that often isn't the reason people do it. So Java, so what I'm saying is, let's say you have a really large project and you've invented 20 different objects for this project. It might be handy for you to be able to glance at a relatively short file like this for each of those 20 objects and have it effectively tell you what it's capable of. then you can go and use it. And if you needed to make a bug fix in it or update the capabilities or something like that, that's when you might dive into the implementation and start messing with the wires, right? But external here, this is effectively documentation. In an older language like C and C++, documentation was not embedded. It wasn't part of what was automated in the language. Now, Java comes with something called Javadoc. And I'll just show you this Java. Get us into it pretty quickly. So here's the string class in Java. Notice here we have a bunch of constructors for strings. They're named the same as the class name. So that's the same stuff we're talking about right now. There are methods associated with it. But now the deal here is that this website type of syntax was generated from their code files that they wrote in Java. So the people who wrote the string class in Java, they put these little markup things in there that have that make it compatible with a program called Javadoc. And what Javadoc does is it goes through your files and it generates those web pages for you. So now if you have a really large project that you implemented using Javadoc syntax, just markups, you still use Java syntax, you just put some extra lines before things to mark it up so Javadoc could do its job. If you did that, you're effectively replacing the need for a header file like this. This is my version of the output of Javadoc in an old C++ program. Whereas this would be the same thing that's generated by a tool called Javadoc in Java. Now, the problem is most Java developers don't use Javadoc. They just don't use that tool. So effectively, Java developers don't have the ability to separate kind of a header file from their implementation file, but everything lives in the same file. They can embed their classes inside of like the class where their main is if they wanted to, but I'm pretty much saying never do that unless you're just writing a quick one-off program like these little homework assignments we had where you're just putting a pretty small class at the top. Pretty quickly, that's going to get out of hand, right? You usually want to get yourself kind of organized a little bit better where they sit in different files. And even though it can get a little complicated with files laying all over the place, I think generally you're at least purposefully forced to organize your stuff instead of just having to hunt through one file with all your code strewn about. All right. So even in Java, you would have had the car class in a separate file called car.java. You would have had the person class in a separate file called personclass.java. All right, but Java does not allow you to have the documentation for car and then the implementation for car in two separate files. At least not conveniently. I would say it's pretty true. They don't allow it. You could sort of kind of pull something off that maybe sort of looks like it, but it's not really a thing. So I could argue that for fairly short classes, maybe you're actually gaining something by only having the header file here and actually doing the whole implementation inside the file. Maybe that's okay. But if you want to go full bore, let's experience the old way of doing it. This is more correct because this is effectively my documentation for my car class. And here's the implementation for my car class. You can imagine implementations are probably going to have a lot more code associated with them. So maybe you wouldn't see the constructor and the display method right next to each other like this. You might have 300 lines in between them. Might be a lot harder to kind of look at it. So this is what I'd recommend for now, splitting them up. The thing you need to be careful of, though, is when you go and write your implementation. So we're including the header file. You need to make sure you use this little magical syntax, because if you don't do this, if I leave that guy off, I'm saying, oh, I'm just going to write a constructor here called car that has this stuff in it. When I run this guy, it's going to say, I don't know about this guy. I don't know who that is. because I didn't link it to anything. I imported car.hpp in here, but now I'm just randomly writing code somewhere, never actually linking it to this thing that's in here. So what does this mean when I say include car HPP? What it's doing is literally this. It's replacing that line with all the code from that other file. Does that make sense? So nothing keeps you from writing it this way either. But good programming practice would have you put your documentation in the header file and put your implementation in the CPP file. And then you probably use it someplace else. In this case, we're using it in main.
So you have to put car.cpp as well?
No, see, it works already.
Well, it doesn't because.
I didn't put the other thing back. All right, so this guy still works. So then the question is why? He's asking, well, why did I put car HPP here instead of car CPP?
Why, or both of them?
Okay, so this guy's talking about multiple definitions is actually a very interesting thing why this happens. So a compiler is going to go through all of your files that are involved in a project. So in this case, it's going to go through, it's going to start with main. It's going to say, okay, I need to bring in standard io.h. I need to bring in IO stream, standard lib, time, string, and oh, here's this guy. Now notice that all these other ones have these little angle brackets, but car has double quotes on either side of it.
Yeah.
The double quotes say that's something that I wrote. Look in the local directory for that dude. Okay, so whenever you're importing or including something that you created, you're gonna put double quotes around it because you're saying this is a local thing, not something that's part of external C++ libraries. All right, well, but a compiler is gonna go through and it's gonna, as it hits each of these, it's gonna go and it's gonna compile the car CPP file. It's gonna look for these implementations of the stuff from that header file. So it's gonna find that stuff and compile that file. So somewhere it's gonna have object code for a file called car. Somewhere it's going to have object code for a class called person class, since we still have that inside of our main. It's going to have all those things. What we're doing here inside of main is we're saying, look, you're going to run into some stuff below, presumably, like I create a couple of instances of cars down here, right? You're going to run into me talking about something called a car. And this falls into the same category as us like prototyping our functions. You're gonna see me babbling about cars down here, and here is the stuff that cars are allowed to do. The implementation is going to be somewhere. I promise the compiler will figure it out and will store that somewhere. It'll be there when you need it at runtime. Okay, but the header file says, look, here's a description of what it's called and what it can do so that you can error check me down here when I'm trying to use it. Does that make sense? So if I didn't put display in here, I call this guy like display 2. It's going to yell at me and it's going to say, hey, it doesn't have a guy named display. How does it know it didn't have a guy named display? Because you told me about car HPP and you don't have it in there. Now, it'll be interesting here if I say, yes, he has a thing called display, but I don't actually implement it because I implemented something called display 2. At runtime, notice it's in blue. So it tried to run it. It compiled fine. It said, hey, look, you told me you tried to call display. You told me about display. Everything looks legit. But at runtime, it's saying, look, there's no function called display 2. This actually would have been a compile time. It's saying like, hey, you're trying to implement something you didn't tell me about. But at runtime, when we were trying to call display, I'm guessing that did flag it at runtime. That's why it's in blue. because it didn't even try to hit the documentation for it until later on. I'm not sure on that one. But in any case, I've promised that there's going to be something called display, presuming that it's going to eventually get implemented. I just happen to never implement it. I implemented something called display too. But from main's perspective, I've promised that you will find capabilities that are found inside of car HPP, which is just this stuff. You will find a class called car that knows about these two things and has these abilities, a constructor and a single function called display. All those things are promises, not implementations. We're relying on the compiler to eventually go and compile this guy and get those implementations and link them back to that promise. And that's the syntax here. Notice that for functions, you link it based on the function name, not the return type. So we're saying we are implementing a function named display, which lives inside car. The return type is outside of that guy, where constructors don't have return types. So it's linked to the constructor name. All right, that makes some sense. So if we were going to come out here, we're going to say, what's a header file? A header file is we're going to call it self-documenting file that lists the fields, constructors, and methods associated with a class, or in older C programming, perhaps a set of functions that will be, maybe that we would say that you would otherwise prototype at the top of the file with main in it. So the main use of these header files is to pull things out of main to have the focus of your code be on main being the driver, kind of the quarterback of your program, and all the other stuff is stored in other places, and it goes and finds those things when it needs those things. But from a human being looking at what does this program do, they're able to focus on main and then dive into these other places if they want to kind of follow the breadcrumbs. All right, so if we're thinking about this from an object-oriented perspective, a header file is effectively a self-documenting file that lists the fields, constructors, and methods associated with the class. And I'll say, note, a header file traditionally does not have the implementation of the code, although nothing prevents you from having it in that file. The idea is to have the header file be concise, so you can glance at the abilities that will be available, not necessarily see how they are implemented. They do eventually need to be implemented somewhere. All right, so we can't just get away with like, hey, this is what I'm going to do, and just C++ will just kind of figure it out. I'm just not going to write the rest of this. You got to write it somewhere, but we're kind of like a trickle down effect here. And ultimately, it comes back to having your code be documented. All right. One thing you could make the argument for is, well, I can go ahead and put my implementation of car inside of the header file and maybe just put good comments before each thing. I'd say you could put the comments in here anyway. So we can say constructors. We can call these guys methods. These guys are the fields. So I can throw some comments in there, just label these guys. Here are the variables owned by this class. Here's the different ways you can build this class. In this case, I have one way. And then here's methods. Okay. Now I can have a second constructor. I can say car takes no parameters. And then I can go in here and I can implement a second constructor and set this number of wheels equal to -1. This name is equal to generic, not a car. LOL. Something like that. So now there's two different ways of building a car. I can build a car actually giving it reasonable information and have it go ahead and initialize the variables to that. Or I can give a car giving it no information, which it has a way of building that. And this guy will go ahead and build you something stupid. He says, look, I'll set your number of wheels to -1, whatever that means. And then I'm going to give it a dumb name. But hey, I built you a car object. So now out in main, when I'm building my cars, I can say car pointer C3 is equal to a new car, calling upon that constructor. Then I can tell C3 to display himself. So there's C3. And what do we see inside of car HPP? I mentioned when we first started talking about objects, let's go back to the notes, that objects, class is a collection of fields, constructors, and methods. Those are the members of all classes. Now, you don't have to have any fields. You get a constructor that takes no parameters, that does nothing. And I can kind of show that to you here. Actually, will that be true if I defined my own? Let's test that. In Java, it would not be. Since I wrote my own, I would not get a no argument constructor, but it's possible. C++ doesn't police that. Let's just test it real quick. Yeah, it didn't give me my a no argument one. But had I not written a constructor that takes some parameters, it would have provided me with a constructor that takes no parameters that does nothing. So it would have been whatever the default value is for an int and a string that it would have loaded in there. I would say you should never rely on that, but if you want there to be a constructor that takes no parameters, you write that constructor and you initialize. This kind of goes back to that idea of never rely on the default values of variables. If you want the number of wheels to default to -1 and the name to default to generic, not a car, write a constructor that does that. Or if you want it to be the default value to be a 0 and the empty string, write something that sets it to 0 and the empty string. Don't just rely on the fact that, oh, I think ints default to 0 and I think strings default to nothing, the empty string. Don't rely on your knowledge that a value defaults to something like that. All right, so a class is a collection of fields, constructors, and you can have more than one constructor. There's more than one way to build a car. You don't have to have more than one, but you could. You could have more than one. We go back to the string class here in Java. See, there's a whole bunch of ways to build strings. I can build strings with no parameters. This guy initializes a new string, that's the empty string. I can give one a byte array and he'll build a string out of that, just a collection of character bytes. I can build one out of a char array, I'm assuming, somewhere down here. Here's one out of a char array. I can build one out of another string, kind of a copy of it. I can build one out of a string buffer. So I got a whole bunch of different ways that I could build a string here. Notice that every single one of these guys is named string because that's the class being defined here. And even though we're looking at Java right now, it's equivalent to what we're talking about in C++. Does that make sense? So you could have more than one constructor, but only if it makes sense. Similarly, a class, we said, is a collection of fields, 0 or more fields. I'm going to say, for all intents and purposes, at least one constructor. Even though you can choose not to write your constructor, it's going to give you one that takes no parameters and does nothing. It would be very, very, very bad programming practice to ever rely on that. You should always have at least one constructor. If you want to have one that takes no parameters and sets your default values to something, you write it yourself. All right, so we'll say at least one constructor and then 0 or more methods. Your classes don't have to do anything. They don't have to have any special abilities. They just could have some special abilities. All right. So what I've done in here is I've gone through and I've just put a couple of comments in my, gotta get the red out of there. Inside of my car class, I just said, hey, this is where the fields are. This is where the constructors are. This is where the methods are. And they don't have to be in any sort of special order. All right, we're going to talk about this public section here in a minute, but for right now, you can just say everything's in a public section. We're going to introduce a private section in a second. Okay. So questions about any of the stuff we've talked about so far? All right, so let's go and look at our current problem with this. Because my fields are currently public, everybody has access to them. If they have access to this car class, they have access to everything that's public about the car class. So let me give you class security. And actually, I'm going to put that down right after the header files. So we have public, private, and now this last one is something that's evolved over the years. In C++, we have a security thing called friend. So in most of our modern languages, we have a thing called protected. They call it friend in C++. And this guy involves inheritance. We will discuss this later. So I'm not going to get into that right now. The first two are easier to explain. Inheritance is when, like, for instance, in this room, we have a bunch of life forms. Specifically, these are humans. So all humans are life forms. Okay, but not all life forms are humans. Right? So somewhere there's a most generic, my heart's beating thing, you're a life form, and then you've inherited from that a new class called human, and a human is everything that a generic life form is, and then some more. And then off humans, we have male and female and so on and so forth. We could have specialized versions of that. So you could have multiple inheritance as you go down the line until you get to something very, very, very specific. Okay. So this last thing, this deals with security related to inheritance. Let's pause on that for right now. We'll just focus on these first two. Public says any class member. And when I say class member, I'm saying any field, constructor, or method. Those are the members of a class: field, constructor, and method. Any class member is accessible anywhere this class is accessible. And I'll show you some examples here in a minute. Things that are in the private section, any, here, I'll just label these. Any public class member is accessible anywhere. Any private class member is only accessible within this particular class. Okay. And let's kind of see what the, and I mentioned this is class security. Let's see if we can show some examples of where this kind of becomes an issue. So I'll go back out. So notice right now, everything is public, right? So that means I have access to these things directly from any place that has access to the car class. That would mean I have access to it here in Maine because Maine has access to the car class. So what I can do is after I've created this Corvette, C1, I can go in and say C1, number of wheels is equal to 13. C1 display. And notice here that I've done some modifications to that instance of a Corvette. Effectively, you walked up to a Corvette parked outside a Target, and you started adding some wheels to it without the owner's consent. Go ahead.
Is that a copy or is that?
Still the original. Yeah, this is the original. I've only created memory once.
Okay, gotcha.
Yep. So here's my car C1. New memory was created once. I proved it was originally created with 4 wheels, right? But because those fields were public, I was allowed to, outside of that class, make modifications directly to those fields. Does that make sense? Now, we would say, in fact, I would generally say, this is always a bad idea. Generally speaking, I would say make everything private initially, and then loosen the security a little bit as you need it to be. So let's explore this a little bit. So now I'll leave my code like this, which we just saw working, right? I created my car C1, displayed it, everything looked good. Then I externally modified it without any sort of oversight. And saw that I was allowed to do that because it was public. I go back into car HPP and I create a private section. And I'll go ahead and move all my fields into the private section. I'm allowed to have some fields that are private and some that are public. Okay, any member can be private or public. It can't be both, but you can have them, you can mix and match. But only the public things are accessible outside of this class. The private things are only, well, the public things are accessible inside the class too. They're accessible everywhere. The private things are only accessible inside this class. So just by moving the location of these guys up to private, notice it's screaming at me now. It says, look, dude, you don't have access to that private field. You can't just start changing this. Make sense? Okay. Go ahead. No. Yeah, to prove that it had changed. You didn't have to, but if you wanted to prove to yourself that the values had changed, you need to display it one way or another. So now this line is illegal. I don't have access to this private member of this instance of the car class because I'm accessing it in a class, in a location that is outside of the car class itself. private members are only accessible inside the class called car. All right, make some sense? So now the next question is though, well, let's say I want to allow people to make changes to the number of wheels. Well, I could just make that guy public, right? I could say, okay, well, we'll leave the name alone, but we'll make number of wheels public, and now it'll work again. But I might say, you know what? I want them to have the ability to change the value of the field, but I want to have some oversight. Like, I don't want them to be able to set the number of wheels to a negative number. Right now, I can come in here and I say the number of wheels is actually -4. Okay. And now you have something that only makes sense in X files. Does this age group, does everybody know what X files is?
I know.
This morning I was in a meeting, and a lady from the meeting referenced, she said we were calling this meeting something called coffee talk. And you know what I'm talking about, right? Anybody else, when I say coffee talk with that kind of a New Yorker accent, clueless, right? It's an old Saturday Night Live thing from years and years and years ago, where they had a show where it was, two people that were they would sit there and have a conversation, kind of like the show The View, right? But they were doing it, and every single time one of the ladies would get upset and start crying and say, I'm getting a little bit clamped. Talk amongst yourselves. I'll give you a topic. She just gives some stupid topic. But so like half the people in this meeting, the older, they got the joke. The other people were like, why did she just change her voice like that? So definitely made me feel, yeah. All the things I used to make fun of my dad for, it's like, okay, well, now I'm hitting those things. It's the only reason that's why I still play video games, so I can keep up with the modern conversation. Well, I like them too, but even games that I don't like, I play just so I know what they're talking about. Do people even play Halo anymore? Oh, what about Counter-Strike? It's more. Okay, so, but these are still in the conversation. They just have niche. Yeah, I gotcha. All right. So the idea here is that I might want to say, look, I want to give you the ability. I'm not sure it makes tons of sense in this particular case, but I might want to give you the ability to change the number of wheels on this car. So let's suspend our reality for a second and say that somebody can just point at a car and say, I want it to have a different number of wheels. But we want to have some level of oversight. We don't want them to just be able to set it to anything. Maybe we want to say, look, you have to have at least one wheel. All right. So knowing only what you know now, how might I accomplish allowing the end user to modify the number of wheels on a car with some level of oversight? Go ahead. Okay. Okay. So I can come into car here, and in my public section, maybe I create a function here called set number of wheels, something like that, and have this guy take in new number of wheels. And then I'll go implement it in my CPP file. And I can do it in any order I want. Now, because this guy set number of wheels, because it is actually, because it's a public method, I would have access to that inside of main, right? But does this guy have access to this private? I'm going to move this back to private here. Does this guy have access to private fields? Does this method have access to private fields here? Yes, because private fields, private members are accessible anywhere inside of, in this case, the car class. And this guy is inside the car class. So he has access to those guys. So now in here, when I implement this, I can say, look, if the new number of wheels you gave me is greater than 0, if you gave me at least 1 wheel, then I'll go ahead and let you set number of wheels equal to the new number of wheels. But only if you pass this criteria. So I've given myself the ability to change that value, but with some level of oversight. You don't have to give it oversight. You could have just let them set it. Nothing prevented you from doing it. But the idea here is that now you get to interject with some logic. You could do that too. You could say, if it's greater than 0 and new number of wheels is less than, I don't know, 100, we'll let you change it. Both of those criteria are met. So now back out here, I can try to change it to -4, and I'll see that it won't have changed. Oh, sorry, I need to call my function. Set number of wheels to -4. And we see we don't get an error because set number of wheels is a public method. I'm allowed to call it. I'm passing in an int, -4. -4 is coming in as this integer, and we're asking a question about it. Is -4 greater than 0? No. So this is immediately, this Boolean expression is immediately false, and we don't do anything in this method. The method will not change our value. Make sense? Well, I could give it output, or I just let it not do anything. Okay, but I can change it to 13. That's between my 1 and 100, right? And now it'll let me change it. There's my 13 wheels. But if I try to change it to 1300 wheels, that's going to be outside my range on the high end. It won't change it. We're back to 4 wheels. Does that make sense? So I would make the argument rule of thumb. Always make fields private and then loosen the security if it makes sense. Now, I might even go on to say, always make methods private as well, and then loosen the security if it makes sense. It's going to be far more common for you to write methods that need to be public, even though you may have methods that work internally that they're only meant to be called from things inside of the class, so you wouldn't actually make them public. If we think about that in real life, we've used the cell phone as an example. This guy right here has lots and lots and lots of abilities, right? All right. Now, some of them I can publicly work with. I have like this volume button and stuff like that. But we believe there are things that can happen that only happen inside of this device that I can't publicly access, but we know they're happening, right? So that means that this instance of this class, the cell phone class, has in it public methods, volume button, on, off, whatever, as well as private methods, things that can only be called by other abilities inside here. Go ahead.
So why do you have like declare
I did. Right here. It was the parameter that's passed into this method. So this is a local variable that lives and dies with the scope of this method. And I passed it in right here. This is the value that got passed in and associated with, it's called, it got bound to that local variable called new number of wheels. And that variable only lived as long as this method was running. Does that make sense? But I am setting this more global variable equal to that local variable that was passed in conditionally, only if it met this criteria. Okay, so rule of thumb, always make fields private and then loosen the security if it makes sense. I'm going to say it is common for methods to be public, but do consider if a method needs to be accessible outside of the class and make it private if the answer is no. And then I'll say it is very, very common for constructors to be public, but do consider if a constructor might be used by another constructor and only needs to be accessed within the class. So you might have a public constructor that starts off by building a base thing with a private constructor that can only be accessible inside of that class. And then he adds some stuff to it. That's going to be pretty uncommon, but it's possible. All right. You can really cover all of these rules by saying, make everything private. And then if you need to access it outside of here, move it over to the public section. And you could just throw all of them under that guise, even though I've kind of given you this idea that it's going to be very common for fields to be private. And then you're going to give abilities to either access them in some way. Sometimes common for methods to be that. Rarely will there be private constructors, but it is possible. Go ahead. Oh, sure. I mean, you could have 2 constructors that are private, and then you could have 3 constructors that are public, but you do need to be able to differentiate them because keep in mind, constructors all have the same name, right? So how will C++ tell them apart? It'll tell them apart by the number and type of parameters, not the variable names. Kind of show you what that means. And let me actually do it with a, well, I can do it with a, for no good reason other than this example. So in my private section, I'll go ahead and create a constructor. We know it's a constructor because its name matches the car name. And this guy takes in an int number of wheels 2 and a string name 2. This guy is a constructor. We know it's a constructor because his name matches the class name. He takes in an int number of wheels and a string name. A human being might look at these 2 constructors and say, oh, they're different because the variable names are different. But from a programming language's perspective, this is a constructor that takes an int and a string. This is a constructor that takes an int and a string. Those are the same constructor. It'll scream at us. Now, if you made it a string then an int, you can, but at that point, you're kind of like, okay, is this something you really want to be doing? But you could build something with, we think about like somebody constructing a house. You could say, well, here's some money, and then here's a bunch of the materials you're going to need to build the house. Or I can just give you a whole bunch of money and then you go and take care of all of it. Two different ways somebody might build a house for you, right? One of them takes two inputs, well, probably more than two, but if we just say materials is a single input, then we kind of cover ourselves. Methods, same rule applies. You could have two methods with the same name, but they have to differentiate themselves by the number or types of parameters that they're taking. But you could have some of them being private, and they would follow the rules of private things, and you'd have some of them being public. All right, but at the end of the day, this logic here will cover you. And if you want to just be extreme with it until you just start seeing the pattern, you can just say, look, I'm going to only have a private section initially. I'm just going to put everything there. And then as soon as I need something to be public, which is going to happen when you run into your first constructor, if you make your constructor private and then you try to construct one of these guys over in Maine, you're going to have challenges. So if I just show that here, if I go in here and just say, oh, I'm just going to move my constructors up here to private, nothing's wrong with that. But if something's private, that means it's only accessible inside of the car class. But you know what? I really want to be able to build cars here in my main CPP. And it's not going to let me do it. It's going to say, well, you made the constructor private. Well, but I want to build cars over here. You're not allowed to do that. You can do it inside of the, if you're inside the car class. Well, how do I get inside the car class if I can't build a car? Well, that's going to be a problem, won't it? So it's going to be very, very, very common that your constructors will be public, because you're going to need some way of building the guy to begin with. And I would say it's going to be very common for your fields to be private. And then we have this idea of something called setters and getters. And we've already seen an example of a setter. These are just kind of naming conventions. So we might say, how do we gain public access to private fields? So we've already done an example of this. We wrote a function that let us change the value of a private field publicly, but with some oversight, correct? Historically, we had something called, let's see, what was it? Accessor methods and mutator methods. Accessor methods give, we're going to say, read-only access to a public or to a private field. Publicly. So if we have a private field, but we want to let somebody have access to it, like maybe be able to ask a car, hey, how many wheels do you have? We can come in here and we can say, oh, I'm going to go ahead and I'm going to add a function that returns an int, get number of wheels, takes no parameters. And what this guy will do when I write it, is he'll return number of wheels. Number of wheels is private, but I'm allowed to access it from inside the car class. I might want people to only be able to read those values, but not be able to change them, which is probably a lot of the case most of the time. So I'm going to say, look, you want to get access to this private member? No problem. You gain access to him through this accessor method. More modernly, they're called getters, but that's just the name. This is just a function that I happen to make work by saying, I'm going to return this value. I've named him get number of wheels for no reason other than it kind of makes sense. If you want to get the number of wheels, you might name the function get number of wheels. Nothing keeps you from just naming the function that. That's still a getter. It's just a very cryptic getter. And since this guy is public, he has access to the private field number of wheels, and we're returning it. This gives you read-only access to it. This guy won't let you change it, but he'll let you read it. Okay, so now I can get the number of wheels. So I can say something like C out, C1, get number of wheels. Where's my, I took that constructor out. He's no longer a thing. I finished taking him out. So here I see that the number of wheels of C1 is 4. I was able to ask it for the value of that private member through the public method called get number of wheels. Right here. C1, call your public method get number of wheels. What does get number of wheels do? It returns this private field. All right, so accessor methods give you read-only access. We just wrote one of those. Mutator methods give you write access, potentially with oversight, if you want to include logic to prevent changes unless certain criteria is met. Now, you might make the argument that, you know what, if I've given myself a accessor for a private field, and I've also given myself a mutator for a private field and put no additional oversight, effectively, the field probably should be public. If I'm letting people just change it or read from it without any additional logic, make it public. But chances are for most fields, you want it to hold a value. You don't necessarily want people externally to be able to change the value, but you might want them to be able to read the value. So I would say it's probably most common for fields to be private all the time, but then you have public getters for those fields so that externally other parts of your program can access the value of those private fields, but not necessarily change the value of those private fields. That would be the most common case you'd run into. So accessor methods are modernly called getters. Mutator methods are modernly called setters, getters and setters. And those are just completely naming conventions. When somebody says, make sure you write the appropriate getters and setters for something, they're talking about the appropriate getters would be, make sure you give public access to the private fields that people need public access to. Setters would be, make sure you give public write access to the fields that you need to have, to the public or to the private fields that you need to have public write access to. If you talk to a modern day programmer, you'll rarely hear them use accessor and mutator. But that was the name for a long time. Now they're getters and setters. Okay. So we're going to look at creating a class called fraction. So fractions have numerators and denominators, right? All right, so we're gonna have a class fraction that has a numerator and a denominator. These are our private fields. Public, let's call this private members. Public members will be a constructor. And then we want to have a display. So it shows a in a reasonable, shows a fraction in a reasonable way. So maybe something like 1/2. One-fourth or 1/6. 14 20/3, something like that. Kind of looks like what a fraction might look like. So maybe your display method spits this particular instance of a fraction out to the screen in some sort of reasonable way. But then we're going to have an add method. Add takes a fraction object as a parameter and adds that fraction to this fraction. Bolded and underlined. Okay, so this is going to get you thinking about the this keyword for this homework assignment. All right, so if I am a fraction and I'm adding myself to another fraction, I don't need my add method to take myself as well. Hand me another fraction and I will add myself to that fraction's data, his numerator, his denominator, and returns a new fraction that is the sum of the two fractions. That makes sense? Remember that adding fractions requires a common denominator. Denominator, got it. All right, that makes some sense? Go ahead. Well, if you want to test to see if you did it right. Yeah, I don't care if you display it, but yeah, you probably want to make sure that if you did 1/2 plus 1/4, so 1/2 plus 1/4 is going to, the common denominator is 8, right? So that's going to be 6/8. Probably want to display it to make sure you did your math right. So homework, implement the fraction class from the previous slide and test it by creating several fractions and adding them together and displaying the results. A link to the code and the self-assessment. Make some sense what I'm asking you to do? All right, so we're going to take what we did today, and I really want to go back here for a second. I want to super emphasize this part right here. In fact, the hint here would be this. That fraction, that method should look like this. Fraction add fraction f. Notice this only takes a single fraction as a parameter, not two fractions. Why? Because the owner of this add method already knows about his numerator and denominator. through the keyword this. That makes some sense? All right, questions, comments, concerns, bribes? Sure. Oh, next class. Yeah. And I'll put up a link to the current code that we have, so you have kind of a starting point or something to reference.